Hey everyone, welcome back. You sent in some really interesting research this week.
Yeah.
It's all about how we learn best.
hmm
And there's this one idea that I gotta say really caught my attention.
Oh, yeah.
It's this whole thing about tackling problems before we actually know the solution.
Huh. That's interesting. It kind of flips the script on how we usually think about learning, doesn't it? Like,
Yeah,
we're so used to being taught the right way first.
totally. Like you get the textbook, you read the chapter, you do the practice problems, right?
Exactly.
But this is like, okay, here's a problem, figure it out, and then you get the explanation.
Wow.
So that's what we're diving deep into today. Problem solving followed by instruction, or as the researchers like to call it, PSI.
Catchy.
Right. And it might sound a little counterintuitive.
Yeah, I can see that.
Like, are we just setting ourselves up for failure here?
Right.
But the research he's done, it actually suggests that this kind of backwards approach, well, it can be incredibly powerful for really understanding new concepts.
Yeah, and I think it's important to emphasize here that we're not talking about just throwing people into the deep end and hoping they swim.
No, absolutely not.
The research we're looking at, it's not just anecdotes and theories, you know? These are rigorous studies that have analyzed PSI from all angles.
Yeah, they've looked at what makes it work.
Right. And just as importantly, what makes it not work.
Exactly. So our mission today is to unpack all of that for you.
That's right.
We want to figure out when this PSI method is really effective.
Yeah. When does it lead to that deeper level of learning?
And maybe even more importantly, why? Like, what's going on in our brains that makes this work?
Right. What are the cognitive mechanisms that are driving these results?
Exactly. And we want to give you the key takeaways.
We'll give you the shortcut to understanding this whole learning strategy.
Exactly.
And trust me, it's more than just try and see what happens.
No, not at all.
There are these specific design features that the research points to.
Yeah, and those features, they make all the difference. Okay, so first things first. Let's define what PSI actually is.
All right. So in a nutshell, PSI is a specific sequence of how we approach learning a new concept.
Okay.
So the learner is presented with a problem, a challenge.
Right.
And this problem requires them to apply a concept that they haven't actually been taught explicitly yet.
Oh, so they're kind of thrown in the deep end a little bit.
In a way, yes.
Mm.
But the key here is that they're not expected to necessarily get the right answer.
Oh.
The goal is for them to grapple with the problem, to really try to figure it out using whatever knowledge they do have.
So it's different from like pure discovery learning where you're trying to figure everything out on your own.
Exactly. PSI is not about just leaving learners to fend for themselves.
Yeah.
There's a clear structure to it. It's problem solving first, and then after they've had a chance to wrestle with it,
Yeah.
then they get the instruction, the explanation.
Okay, so it's very deliberate. It's not just like, oh, I'm going to try to solve this thing and see what happens.
Right, exactly. It's a carefully designed learning sequence.
Now, you mentioned that the learners aren't necessarily expected to get the right answer in that initial problem-solving phase.
Yeah.
So mistakes are okay.
More than, okay, they're actually seen as a really valuable part of the process. There's even a term for it, productive failure.
Productive failure. I like that.
Right. It sounds counterintuitive, but the idea is that by making mistakes, by hitting those roadblocks,
Yeah.
learners actually develop a deeper understanding of the problem, and then they're more prepared for the instruction that comes later.
They've kind of already explored the dead ends.
Exactly. They've tested their assumptions, they've seen what works and what doesn't.
And they probably have a lot of questions at that point.
Absolutely. Which makes them that much more receptive to the explanation.
Okay, that makes a lot of sense.
And there's another PSI approach
Mm.
that's often cited.
Oh, yeah?
It's called invention.
Invention, huh? What's that about?
So with invention, learners are asked to come up with their own methods or solutions for a problem,
Oh, interesting.
like before they're taught the official or standard way of doing it.
So instead of just memorizing a formula or following a set of steps,
Right. They have to get creative.
they have to really think about the problem and how to approach it.
Exactly. And this act of invention, even if the solution isn't perfect,
Yeah.
it sets the stage for more meaningful learning when they are presented with the standard method.
Okay, so both productive failure and invention,
Yeah,
they're both ways of actively engaging with the problem.
right. And it sounds like there's a lot of research backing up this PSI approach.
Oh yeah, there's a growing body of evidence supporting the effectiveness of PSI. You see, when Professor Kapoor first started exploring these concepts,
Mm-hmm.
like back in the early 2000s,
Okay.
there wasn't as much research out there.
Right.
But in recent years, there's been a surge in studies looking at PSI.
Wow. So it's really gaining traction.
Absolutely. And that's a good sign. It means researchers are seeing its potential.
Well, that's encouraging.
Yeah.
So we've established that PSI can be effective.
But you mentioned earlier that not all PSI is created equal.
Right.
There
Yeah,
are certain design features that are really crucial for it to work.
absolutely. And this is a super important point.
Okay, let's talk about those features then.
All right, so the first one that really stands out in the research is the use of contrasting cases during that initial problem-solving phase.
Contrasting cases. Okay, so what are those exactly?
Well, imagine you're trying to learn a new concept.
Mm,
Let's say, for example, you're trying to understand what makes a soccer player consistent in terms of their scoring.
okay, I'm following.
Now, instead of just being given a definition or a formula,
Yeah.
you're presented with two different players, player A and player B,
Okay.
and you're given their scores for, let's say, the last 4 games.
Right.
Now, these two players, their scores might be similar in some ways, like maybe they both have the same total number of goals,
Okay.
but there's one key difference between them.
Right.
Maybe player A's scores are all very close together.
So like 9 goals, 10 goals, 11 goals.
Exactly. While player B's scores are more spread out, like 5 goals, then 15 goals, then back down to 8.
Okay, I get it. So you're highlighting the difference between like a narrow range of scores versus a wide range.
Precisely. And that's the essence of contrasting cases. You're presenting two examples that are very similar, but differ in one specific important way.
And that helps the learner really focus on that difference.
Exactly. It forces them to think about what actually matters, what makes those two examples different.
Instead of just getting lost in all the data.
Right. And in this case, they're starting to understand that consistency isn't just about the total number of goals.
It's about how those goals are distributed, how close together they are.
Exactly. And then you might introduce another contrasting case.
Oh, so you don't just stop at one pair
Nope. You might compare player B, who we just talked about,
with the wide range of scores.
right, to another player, player C, who also has a wide range, but their scores are clustered differently.
Okay, I'm curious. Give me an example.
So player B might have scored 5, 8, 12, and 15 goals,
Okay.
while player C scored 5, 5, 15, and 15.
Ah, so they both have the same range, but player C is more like boom or bust.
Exactly. And by comparing these two, the learner starts to see that even within a wide range, there are different patterns of distribution.
I see, I see. So these contrasting cases, they're like little puzzles.
Yeah, that's a great way to put it. They're carefully designed to highlight those deep features.
The things that really matter.
Right. And the research shows that when PSI uses contrasting cases like this, it can really boost learning, especially when it comes to transferring that knowledge to new situations.
To being able to apply it in different contexts.
Exactly. Because you're not just memorizing facts, you're understanding the underlying principles.
Okay, so that's contrasting cases. What's the second key design feature?
So the second feature is all about what happens after that initial problem-solving phase, during the instruction part.
Okay, so they've wrestled with the problem. Maybe they've seen some contrasting cases. Now what?
Now it's time to connect all the dots. And this is where it gets really interesting. Instead of just presenting the right answer or the standard method right away,
Yeah.
the instructor actually takes the time to discuss the solutions that the students themselves came up with,
Oh, interesting. So even the wrong answers.
especially the wrong answers, because those can be so revealing.
How so?
Well, they show the instructor how the students are thinking, where they might be going astray, what misconceptions they might have.
So it's not just about saying, nope, that's wrong. Here's how you do it.
Not at all. It's about understanding why those solutions are incorrect.
And using those mistakes as a springboard to the correct explanation.
Exactly. So going back to our soccer example, maybe some students just focus on the total number of goals,
Okay.
or maybe they looked at the difference between the highest and lowest scores,
Right.
but they didn't really grasp the concept of distribution.
So the instructor would say something like, okay, I see that some of you looked at the total goals scored, but what about how those goals were spread out over the games? Does that matter?
Exactly. And they might even put those different student solutions up on the board.
Side by side.
Yeah, and then lead a discussion about the strengths and weaknesses of each approach.
So it becomes a real learning moment.
Exactly. Because when students see their own thinking reflected back at them,
Yeah.
and when they see how their solutions compare to the expert solution, it really helps solidify their understanding.
It's like they're actively involved in constructing their knowledge.
Right. And the research consistently shows that this kind of PSI, where the instruction is built on student solutions, it leads to better conceptual knowledge.
Deeper understanding.
Exactly.
So it's not just about knowing the steps, it's about understanding the why behind those steps.
Exactly.
So what happens when you combine these two powerful features?
When you use contrasting cases during the problem solving
Yeah.
and then build the instruction on student solutions.
Right. It seems like that would be the ultimate PSI recipe.
Well, the research does suggest that combining these two features can be especially powerful. It can lead to even deeper conceptual understanding.
Interesting.
But here's the thing, and this is important. It's not always a simple case of 1 + 1 = 2. You know what I mean?
Oh, interesting.
Some studies have found that while combining these features can be beneficial, it's not always significantly better than just using one or the other.
So it's not like a guaranteed exponential boost.
Right, exactly. It's more nuanced than that. It seems like both contrasting cases and building on student solutions offer unique benefits.
Okay.
And sometimes those benefits are additive, and sometimes they're not.
Fascinating. So it's not just about throwing everything at the wall and seeing what sticks.
No, it's about understanding the subtle interplay of these features.
And how they work together.
Exactly. And that's what makes this research so interesting, right?
It is.
It's not just black and white. They're all these shades of gray.
So what about PSI that doesn't use these key features?
That's where things get really interesting.
Okay, tell me more.
So the studies that have looked at PSI implementations that don't incorporate these features, they often find that the learning outcomes are less clear.
Okay.
And sometimes even negative.
Whoa, negative. Like it actually hinders learning.
Well, it doesn't necessarily make people worse at something,
Okay.
but it doesn't really seem to help either,
Oh, I see.
especially when it comes to transfer to applying that knowledge to new situations.
So it's not just about the order of problem and solution. It's about how those two phases are structured.
Exactly.
The devil's in the details.
Exactly.
So if you just throw a hard problem at someone
Yeah.
and then give them the answer without any connection to their struggle,
Right.
it's not going to be very effective.
It's not going to have that same impact.
Okay, so far we've been talking about the what of PSI.
Yeah.
Like what it is, what the key features are.
Right.
But now I want to get into the why.
Okay, I like where you're going with this.
What's actually happening in our brains when PSI works?
So we need to delve into those underlying cognitive mechanisms.
Exactly.
Why does this approach, this seemingly backwards approach, why does it lead to such positive results?
Yeah, and I'm particularly interested in how those key features we talked about, how do those play into it?
All right, well, the research has identified a few key mechanisms that seem to be at work.
Okay.
And the first one is what they call activation and differentiation of prior knowledge.
Okay, that's a mouthful.
It is, but it basically means that when you encounter a new problem,
Yeah.
your brain automatically starts searching for any relevant information it already is stored away.
So it's like you're pulling out all your mental tools.
Exactly. You're rummaging through your mental toolbox and saying, okay, what do I already know that might be helpful here?
Even if you don't know the exact answer.
Exactly. And even if what you think you know is incomplete or even incorrect,
Why?
the act of searching, of activating that prior knowledge,
Yeah.
that's what's important.
And is there research to back this up?
Well, yeah. There have been studies that have shown that when students try to generate their own solutions to problems, they activate their prior knowledge more effectively than when they simply evaluate pre-designed solutions,
Oh, interesting. So it's the act of trying, of struggling, that really gets those gears turning?
Exactly. It's not passive. It's active learning.
Okay, but wouldn't just activating any old prior knowledge be a problem sometimes?
Oh, absolutely. Sometimes what we think we know can actually lead us down the wrong path.
Right. So how do we avoid that?
Well, that's where the second mechanism comes in. Awareness of knowledge gaps.
Okay, so we're not just activating any knowledge, we're becoming aware of where our knowledge is lacking.
Exactly. And that's one of the things that makes PSI so powerful.
Mhm.
When you struggle with a problem before getting the instruction,
Yeah.
it forces you to confront what you don't know.
It makes you realize, oh, wait a minute, I don't actually understand this as well as I thought I did.
Exactly.
Uh-huh.
And studies have shown that students who engage in PSI, they report a much greater awareness of these knowledge gaps.
Compared to students who are just given the instruction up front.
Exactly. And this awareness, this realization that you don't know something,
Yeah.
it makes you that much more receptive to the instruction when it finally comes.
Oh, totally. It's like you're primed for that knowledge.
Exactly. And this is where those key features we talked about earlier,
Yeah.
they come into play again.
Okay, how so?
Well, think about those contrasting cases.
Mm-hmm.
When you're comparing those two examples side by side,
Yeah.
and you're trying to figure out what makes them different,
Right.
You're more likely to realize where your understanding falls short.
You might start to think, oh, I thought I understood this concept, but now I see that I'm missing something.
Exactly.
Mm.
And then when the instruction comes along
Mm-hmm.
and the instructor explicitly addresses those common misconceptions, those knowledge gaps.
That's when the light bulb really goes off.
Exactly. So
Mhm.
those features, those design choices,
Yeah.
they're not just arbitrary.
Yeah.
They're intentionally designed to trigger these cognitive mechanisms.
To make us better learners.
Exactly.
Okay, so we've activated our prior knowledge. We've become aware of our knowledge gaps.
Yeah.
What's the third mechanism?
The third mechanism is all about recognition of deep features.
Okay, deep features. What are those?
So every concept has these surface features.
Okay.
These are the things that are immediately apparent,
Mm-hmm.
but then there are the deep features. These are the underlying principles, the core ideas that are often less obvious.
Okay, so it's like the difference between knowing the rules of grammar and actually understanding how language works.
Exactly.
Mm.
Or in our soccer example, it's the difference between knowing that a consistent player scores a lot of goals and understanding that it's actually about how those goals are distributed over time.
Right, right. So how does PSI help us recognize these deep features?
Well, by grappling with the problem first, by trying different approaches, even making mistakes,
Yeah.
you start to develop a more nuanced understanding of the concept.
And those contrasting cases, they really help highlight those deep features, don't they?
They do, because you're forced to compare those two examples.
Side by side.
Exactly. And focus on that one key difference that sets them apart.
And then when the instruction comes along, it can build on those insights.
Exactly. And by explicitly addressing those deep features, it helps learners encode that knowledge in a more meaningful way.
So it's not just about memorizing facts, it's about understanding the underlying structure of the concept.
Precisely.
Mm.
And this recognition of deep features is crucial for transfer.
For being able to apply that knowledge to new situations.
Exactly. Because when you understand the deep features, you're not just stuck with a bunch of isolated facts.
You have a framework for understanding new information.
Exactly. You can see how those facts fit together, how they relate to the underlying principles.
Okay, so we have these three mechanisms.
Yeah,
Activation of prior knowledge, awareness of knowledge gaps, and recognition of deep features.
yep, those are the big three.
And they all seem to work together.
Oh, absolutely. There's this kind of cascading effect.
Tell me more about that.
Well, the activation of your prior knowledge, that leads to the awareness of your knowledge gaps.
Mm-hmm.
And that awareness then makes you more receptive to recognizing those deep features during the instruction phase.
It's like each mechanism builds on the previous one.
Exactly. Like
Yeah.
building a house. You
Mhm.
need a strong foundation of prior knowledge.
Right.
Then you need to identify the gaps, the places where you need to add more support.
Okay.
And then finally, you can start to see the structure, the deep features that hold it all together.
Wow, that's a great analogy.
Thanks.
So this all sounds very promising, but I have to ask.
Yeah.
Most of the research we've been discussing seems to focus on mathematics.
That's true.
Does PSI work as well in other subjects?
That's a great question and an important one. And to be honest, that's something researchers are still exploring.
Okay.
The majority of the research has been in math education,
Mm.
but there are some studies starting to emerge in other fields, like psychology, for instance.
Oh, interesting. And what are the findings?
Well, they're finding some promising results. It seems like PSI, especially when it incorporates those key features we've been talking about, it can also be effective in these other domains.
So it's not just a math thing.
It seems not to be.
That's exciting.
Yeah, it is. But, more research is definitely needed to confirm this.
Of course.
We need to see how PSI works in different subjects, with different age groups, and different learning styles.
Right, because what works for one group of learners might not work for another.
Exactly.
So what are some of the limitations of the current research on PSI?
Well, one thing to keep in mind is that while we have solid evidence for the role of prior knowledge activation and awareness of knowledge gaps,
Mm-hmm.
the evidence for that deep feature recognition mechanism, it's a bit more indirect.
Okay, so we need more research specifically targeting that mechanism.
Exactly.
Yeah.
We need to design studies that can really isolate and test how deep feature recognition contributes to learning.
And as you mentioned earlier, we need more research in different subject areas.
Absolutely. We need to see how PSI works beyond mathematics.
And are there any other areas where the research could be expanded?
Well, one thing that's really interesting to me is the role of motivation.
Oh, yeah. Because if you're not motivated to engage with the problem in the first place,
Exactly. then PSI isn't going to be very effective.
So how do we make PSI motivating for learners?
That's a great question. And there's definitely a lot of room for research there. We could look at different ways of presenting the problems, different types of feedback, maybe even different reward structures.
Right, and how about the role of collaboration?
Oh, yeah. That's another area that's ripe for exploration.
Because sometimes working with others can really help us understand a concept.
Absolutely. Especially when we're struggling.
So we could look at how different collaborative learning strategies might enhance the effectiveness of PSI.
Exactly. So, as you can see, there's still many unanswered questions.
But that's what makes research so exciting, right?
It is. It's all about pushing the boundaries of our knowledge.
All right, so let's bring it all together.
Okay.
What's the key takeaway for our listeners today?
I think the main message is that PSI can be a really powerful learning tool,
Yeah.
but it's not as simple as just giving someone a problem and then telling them the answer.
Yeah, it's much more nuanced than that.
It's all about those key design features.
The contrasting cases, the building instruction on student solutions.
Exactly. Those are the things that make PSI really sing.
And that initial struggle, that's not just busy work.
No, not at all.
It's actually priming our brains to learn.
It's setting the stage for deeper understanding.
So when the explanation finally comes, it really clicks.
It does, it does.
This has been such a fascinating deep dive.
It has.
And I think it has some really important implications for how we approach learning.
Absolutely. Whether we're students, teachers, or just lifelong learners.
So for all of you listening out there,
Yeah.
here's a little challenge for you. Think back to a time when you learned something particularly well, and maybe you struggled with it at first.
Yeah, those aha moments.
Exactly. And see if you can identify how some of these mechanisms we talk about today might have been at play.
Like, were you aware of your knowledge gaps? Did you suddenly recognize a deep feature?
Exactly. And what if you started intentionally incorporating this try it first approach into your own learning?
Like actively seeking out contrasting cases or reflecting on your initial attempts?
Exactly. It's a powerful way to learn.
It really is.
Well, that's all the time we have for today.
Yeah,
But we hope this deep dive has given you some new insights into the amazing process of learning.
absolutely.
Thanks for joining us.
And keep those research papers coming.
We love to see them.
We do.
All right. Until next time.
Take care, everyone.
Bye.
Bye.